Good afternoon, lovely humans. Today we are going to be looking at section 10, 1, 2. We're going to be working more with these arithmetic series. Remember, a series is like a sequence, but instead of just a list of numbers, it is that list of numbers added up. Go ahead and take a look at the first problem, 10-25. It should be mostly review, and we'll go over it in a moment. Alright, so coming on back, for 10-25A, you can write a lot of different things. Basically, you know that the way things are going, you're going to be matching up these 16 columns to make 8 new columns, and all of them will have a height of 13, and that's like the definition of a rectangle, is to have a uniform base, uniform height. For part B, the sum of this series is going to be the base times the height, basically the area of the rectangle, so in this case 104. The first term was 2 and the 16th term was 11. So then the height of each of the columns, like we said, was 13. And then part D is a little bit tricky because you do have to figure out, like, it asks you to write out the series, so you have to figure out what the terms are. And you know that the first one's 2 and the last one's 11, but it's kind of hard to tell what the next one up is and like what the common difference is. So here, what I've written is basically delta y over delta x, except we're in sequence land, so it looks like delta t of n and delta n. So we know that we change by a factor, we go from 2 to 11, so 11 minus 2, and then we go from 1 to 16, so 16 minus 1. So that's going to be 9 over 15, also known as 0.6. And that's going to be your common difference. So that should allow you then to write out, you'll have like 2 plus 2.6 plus 3.2, and so on. Just keep adding 0.6 all the way until you get to 11, which is equal to 104. Make sure you write all of those out. That would be your series. Awesome. So let's take a look at 1026 and 1027. So they're both like not multi-part problems. And for 10-26, it does say you can use an example if you'd like. You may use my example if you want to. So the most simple series I could think of that had an odd number of terms was 1, 3, 5, 7, 9. So you can use that one. You can make up your own, whatever you want to do. But that's what we're going to be looking at for the next problem, is kind of trying to generalize this if it's an odd sequence. See if there's an odd number of terms in the sequence. Okay, so give it a shot. 1026, 1027. All right, so for 10-26, I'm using the example of 1, 3, 5, 7, 9 as the sequence. Not only are the values odd, but what was really important was that there are 5 terms, right? So everything we've looked at so far, or most things that we've looked at, have had an even number. That way you can pair them off and make a nice rectangle with whole numbers. But it still works actually if it's odd, and I'm going to show you how. So if we take this 9, you start just the same. So we're going to take that 9 and put it here to make a 10 column. And then you can take this 7 and put it here to make another 10 column. And then you can actually split this guy in half and put half of it on top. It's kind of ugly, but it'll do. Right, so then we have 5 and 5. And this is just 2 and a half, right? So if you split this block in half, then we really end up with a width of 2.5 and a height of 10. So we still take the number of terms, divide it by 2, that's going to be the base. And then the height is still going to be the first and last terms added together. And that can be said for any arithmetic sequence, as long as it grows by a consistent amount. So however you want to word that in your explanation for 10-27, that is up to you. Next, we are going to look at 10-28. So I'm trying to think if there's anything I should warn you about. I think it's pretty straightforward. There is one slightly tricky part in figuring out the number of terms, but I think with your knowledge of slope, or you can just like list them out, you'll be able to figure it out. So 10-28, parts A, B, C. So for 10-28, part A, the tricky part is that they don't tell you how many terms there are, so you need to figure that out. I kind of did it. I always get confused. Some of you may have just been able to like do it in your head, like, oh yeah, the difference is 7, and 74 minus 11 is 63, and 63 over 7 is 9, so you go up 9 times, and there's 10 terms. If that's what happened in your head, that's great. I always mess myself up when I try to do too much in my head, so I set up this equation that I know is true, let the algebra do the thinking for me. So I know that the common difference is the change in y over the change in x, or in this case, the change in the term value divided by the change in term number. So that's 7, right? And then I knew that my first value was 74, my last one was 11. I don't know what the last term number was, but I know that 11 was the first one. So just like y2 minus y1, x2 minus x1, what we're solving for is n in this case. So then you can multiply on both sides, so you get 7 times n minus 1 equals 63. I'm going to go ahead and divide by 7 on both sides, just for fun. Usually we would distribute first, but it doesn't actually matter. And so we get n equals 10. So we have our 10th term. 74 must be the 10th term, which means that we are going to get, this is kind of like the formula that we can use. We're going to have 11 plus 74 is going to be the height of our rectangle times the base, which is going to be 10 over 2. And when we multiply that out, we get 425 as the sum of our series for part A. Part B, they actually give us like everything we want to know, right? So they tell us that the first term is 8, and then we have 151, or maybe it was the other way around, doesn't matter. There are 14 terms, so we're going to add these up to get 159, multiply that by the number of terms, 14, divided by 2, that'll be the base of our rectangle, and we'll get 1,113 as the sum of our series. And finally, part C, they give us the equation, and so we actually have to figure out what t of 1 and t of 25 are. So we want to just plug it in. So I'm going to plug in 1 and then 25. So we can see that our first term is going to be, what is it, 4, right, because we're in first term form. And the 25th term will be 148. So what we want to do, same as we've been doing, you want to add them up. So 4 plus 148 is going to be that column, the height of the rectangle, the base. We are going to take 25 and divide it by 2. And then we will get a nice clean number, 1900, as the sum of our series. Cool. Go ahead and try out 10-29. Okay, 10-29, here we go, and then we are done for the day. So 10-29, it asks us about that problem we were working on in a previous classwork. The awesome uncle who just like gives you a ton of money, and we're going to figure out how much by your 18th birthday. So, we know that we started at $50, right? That's the first piece of what we need to know. We also need to know, on that 18th birthday, like how many months will that have been, right? Because we're measuring in terms of each month. So we need to do 18 times 12, which is going to be 216 months. And that's the value that we need to find out, how much was deposited on the 216th month. That's like our last term. So plug it in, 216, all this junk. We will get 695. And now we are ready to plug into our formula. So we have t of 216, t of 1. That's what we plug in here. Or let me line it up correctly. So 50 plus 695 times 216 divided by 2. And your uncle must be a very rich man because he is giving you $80,460 in total by the time you turn 18. Where is this uncle in my life? We may never know. And that's all for today. So have a great rest of your day, and I will see you next time.